release of adrenaline from the adrenals that has action within the body, elevated heart rate, blood pressure, etc. And then adrenaline also from the adrenals to the vagus, from the vagus to the NST, NST to locus coeruleus, and then locus coeruleus sprinklers the brain with this norepinephrine, raising the levels of baseline activity in all those brain areas and making them more likely to be engaged by things that we're trying to attend to, more likely to engage, say, the neurons of the prefrontal cortex that can learn context-dependent strategy switching, such as in a Stroop task, or when we're trying to attend to information and we go, okay, here's something important, I need to pay attention to this. We're able to do that because of that elevated level of norepinephrine. It facilitates, it's permissive for elevating our levels of attention and focus. It's also permissive for our hippocampus to encode new memories and for a bunch of other brain areas to do their thing, so to speak. So knowing these mechanisms is actually worthwhile. If you've ever heard exercise can give you energy, this is the basis of that statement. Many people, in fact, myself for many years thought, okay, I definitely have to sleep well in order to have energy and focus. That's absolutely true. Still true, will always be true. I should maybe have some caffeine, be hydrated, well-nourished, all this stuff in order to have the energy to exercise. But it's also true that exercise gives us energy, and this is how it gives us energy. When we move our body, the adrenals release adrenaline, and the adrenaline acts through two different so-called parallel pathways within the body, but again, it doesn't cross the blood-brain barrier, so then there's a series of what we call signaling relays or circuit relays up to the locus coeruleus, and then a sort of analog, it's different, but an analog to epinephrine, norepinephrine, is released within the brain